I was born and raised in Connecticut. I knew by the 4th grade I would be a scientist, and by 8th grade an astronomer. I was very active in high school as an amateur astronomer, graduated in the top of my class, and was one of the top 10 national winners in the 1950 Westinghouse Science Talent Search. I graduated magna cum laude from Harvard in 1954, having begun active research at Harvard Observatory in the new area of photoelectric photometry. I actually became a member of the American Astronomical Society in 1953 as an undergraduate, and received a PhD in astronomy and physics from the California Institute of Technology in 1958, where I continued active photometric research within the galactic and extragalactic fields. Following 4 years as a National Science Foundation predoctoral fellow at Caltech, I was honored by a 2-year postdoctoral National Science Foundation fellowship in 1958 through 1960. At Mount Stromlo Observatory in Australia, I carried photometry down to the 20th magnitude to examine the distance scale and stellar populations of the Magellanic Clouds. In 1960, I returned to the USA as a research associate for a year at Vanderbilt University, followed by 3 years as astronomer at Lowell Observatory, where I further extended my nuclear and radial photometry of galaxies begun at Caltech. In 1964, I accepted an associate professorship at the University of Arizona to open a space astronomy laboratory. In 1965, I was actually one of 16 finalists in the first scientist astronaut selection. But I returned to my interest in galaxies and cosmology by 1970. I assumed a full professorship in 1973 at Stewart Observatory, active in teaching and research. I concluded my academic career at University of Arizona in 2002 as Professor Emeritus. Overall, I have published over 100 professional articles and received many grants. The scientific keynote of that period and subsequent years has been formulation of a new cosmology, quantum temporal cosmology, QTC. My social keynote was my 1965 marriage to Janet Homewood, a wonderful local artist. A second marriage for both of us that led to raising a his, hers, and ours family. In 2016, I created the Janet A. and William G. Tifft Arts and Sciences Heritage Group to preserve and advance our achievements. My beloved Janet, unfortunately, passed away in 2015 after 50 wonderful years together. There are 2 ways to approach cosmology: with theory or real data. Classical theoretical dynamical cosmology is mathematically complex. Assuming space is an expanding universal medium under unlimited gravitational control, where time is one-dimensional and expansion is presumed to be a velocity pattern defined by redshifts. No non-local tests or quality data existed on a large scale in 1930 when classical cosmology was born. Many problems have arisen, but somehow the basic concepts are not questioned. Even when precise data, new data, says it should be. Classical cosmology simply adds new mysteries, such as dark energy, which is not present in QTC. In 1970, a study combining my galaxy photometry with existing redshifts suggested that the redshift data was not a simple velocity. It was, or could contain, an intrinsic component. My suggestion was emphatically rejected. But I fully accept the scientific method, and this problem needed study. So began my lifetime study of the redshift, leading to quantum temporal cosmology. QTC begins with the birth of time and its inverse energy, and finds no evidence for large-scale gravitational dynamics between galaxies in many careful tests. The data implies that the large-scale cosmic medium of time consists of a quantized spherical system of temporal energy levels about the origin, between which galaxies decay in a doubling process, generating quantized periodic redshift patterns. The same doubling process within particle physics is shown in QTC to define or construct the fundamental particles and define the spatial fundamental forces. QTC defines a fundamental energy and structural unit I designated as the triad, which generates quark structures and appears to relate to leptons and neutrinos. The spatial forces exist only where time, referred to as aging, is continuous and constrained around spatial particles, which include galaxies as big ones. In QTC, galaxies literally define space, a fermionic, continuous spatial compressed nodal core to satisfy quantum simultaneity through entanglement with its extended quantized bosonic temporal wave function energy level. Timelines pass through a universal three-dimensional spherical temporal medium, pausing at fixed doubling points, about which its nodal continuous spatial time then flows radially about the fixed cosmic time. The temporal commonality of the cosmic time provides instantaneous transmission of the forces defining space, while spatial aging distorts the cosmic wave function to drive the next doubling step. In QTC, the galaxies appear to be digital clocks, which step through quantized cosmic time in doubling redshift steps, driven by the continuous aging escapement effect of their nodal spatial continuous radial evolution. The escapement feature is a decaying temporal dipole, quantum temporal cosmology, has shown to exist in galaxy nuclei. There is extensive evidence for quantized redshift in steps, which can explain major problems in classical cosmology and particle physics. The spherical cosmic temporal structure explains the so-called cosmic flatness problem and causes cosmic curvature corrections. Redshift variations are seen, relative to us, as blue shifts to higher energy in their nuclear dipoles. In QTC, this appears to be spatially controlled decay of an original temporal fluctuation. Photon transfer energy losses between timelines due to temporal curvature is what cumulatively reddens true look-back redshifts from doublings. To yield the true cosmic quantized look-back redshift scale, the continuous reddening cosmic curvature correction must be removed, and a proper cosmic rest frame used to detect the true global look-back quantization within and beyond our local cloud of galaxies. Locally, longer periods were originally and can be seen uncorrected, but they are somewhat distorted. To understand QTC in well-illustrated depth and detail, consult my book, Redshift Key to Cosmology, right there. Published in 2014 and available from Amazon. Much is summarized with updates in my blog at williamtifft.wordpress.com. Janet's art and approaches to art may be viewed at janettifft.com. Updates will also become available through our heritage site at tiftheritage.com. Guidebooks in QTC, cosmology, and particle theory, as well as Janet's art, will be discussed on the heritage site. Small grants to become familiar with QTC and Janet's art may be awarded to qualified applicants associated with appropriate institutions. And contacts from persons interested in our work will be very welcome. If time allows, I can demonstrate some of the early discoveries leading to QTC as presented on poster papers and at meetings, and say a bit about my beloved Janet's art and approaches.